Okay, so the purpose of this video here is to go over a graph that we previously worked on, just to review how to graph the information and also to go over the formula, force times mass equals acceleration. Force is equal to mass times acceleration. So the graph that we were looking at was based on these charts that we had before. And these charts are located in your EDSB. If you look at the activity that I gave you, if you look at the paperwork for the assessment assignment, you'll find these graphs, these data tables there. So I'm going to go over how to graph it. So if you look here, this data table is actually, we're going to use a different color. This data table is force here and acceleration here. So looking at experiment 1, we have a force of 4 newtons. Okay, so that's going to be here, and an acceleration of 2 meters per second. So that's going to go there. Okay, so the next point is a force of 2 newtons and an acceleration of 1 meter per second. So that's going to go here. Let's take that one off. The next one is a force of 20 newtons and an acceleration of 10 meters per second. So that is going to go way over here. Okay, and the last one is a force of 10 newtons, which is here, and 5 meters per second. So we're going to go here. So this, as you can see, it is linear. Pardon my not being able to draw an absolutely straight line. I don't have a ruler. But that there is the first line, and we're going to say that is for experiment 1 data. Okay? You go ahead and make it a little bit more noticeable. So that's experiment 1's data. Okay? Now, experiment 2, the second table that we had. Okay? If we look here, we have a force of 4 newtons. And we have an acceleration of 1 meter per second. So that's going to go here. We have a force of 2 newtons and an acceleration of 0.5 meters per second. So that's actually going to be down here. Let me go ahead and erase this so that it starts at 1. And then a force of 20 newtons at an acceleration of 5 meters per second. So that is going to be here. And then the last one is 10 newtons at 2.5 meters per second. So that's going to be about here. So this is also linear. Again, excuse me for not being able to quite draw a straight line. Plus, I'm approximating in this graph, unfortunately, because it's not a grid. But, and it is supposed to be a straight line. I think I'm a little low over here. Okay, so as you can see, 20 is over here. That's why. Okay, so as you can see, both of these lines are straight. Now, one of the things I want to mention, first of all, when you look, both of them have a lot of similarities. They're both linear. As you can see, as the force decreases, acceleration decreases. Now, we could assume the same mass, and all of these do have the same mass. So no matter what the force and the acceleration is, the first experiment, experiment 1, had a mass of 2 newtons. Experiment 2, which is the red line, had a mass of 4 newtons. since it had a mass of 4 newtons, okay, if you're looking at the same, force with the same mass, or, okay, 4 newtons per, 4 Newton force with a mass of 4 grams versus a mass of 2 grams is going to accelerate less. So if you were applying a certain force, but you are increasing the mass, then the speed is going to go slower. If you think about it, let's say you're pushing a shopping cart. If you apply the same amount of force to a full shopping cart, that shopping cart is going to go at a certain speed. If you apply that exact same force to an empty shopping cart, that shopping cart is going to go faster. So this experiment, for example, could be the full shopping cart. This experiment could be the empty shopping cart, for example. Okay, so that's how you would draw it. And just to give you an idea, this is what the graph looked like. I'll bring it a little bit closer so you can see it. And you can see here, this has a mass of 2 grams, so it has a greater acceleration with the same force applied. This has a slower acceleration with the same force applied, because the greater the force applied, the greater the greater the mass, the less the force is going to be able to impact the acceleration, because it has to overcome the mass. I hope that makes sense. So, hey Kip, how you doing? So that's the first thing. The second thing I want to go over is how to utilize the formula. Okay, so in the book, they asked you to take a look at these experiments, experiment 1 and experiment 2, and find a way to make it work. Okay, so if you look here, if the force is 4, it equals 2 times 2. Okay, so the base formula is force equals mass times acceleration. Okay, so hello. So in this case, this formula can be reworked to solve for whatever you want to solve for. If you want to solve for acceleration, let's say, okay, so if you have force equals mass times acceleration, if you divide both sides by the mass, okay, you get force divided by mass is equal to acceleration. Okay, now if you wanted to solve for mass, okay, you would have force divide, in this particular case, by acceleration on both sides. So force divided by acceleration is equal to the mass. Okay, now some of you have also seen me use this triangle in class, okay, where you have mass here, acceleration here, and force here. You saw me use this triangle with density. It's the same thing. Force is equal to mass times acceleration. Mass is equal to force divided by acceleration. Acceleration is equal to force divided by mass. In other words, if they are next to each other, you multiply them. If they're one above the other, you divide them. So if I want to solve for force, I cover up the F, and it's mass times acceleration. If I want to solve for mass, I cover up the M, it's force divided by acceleration. If I want to solve for acceleration, I cover up the A, and it's force divided by mass. Okay, so those are a few ways that you could remember what the formulas are, so you can utilize them fairly easily. So now, I'll give you a couple of examples. really quick because there will be a worksheet on how to do this. So looking at experiment 1, force is equal to mass times acceleration. Okay, so, and I'll put the triangle up here as a point of reference. Okay, so in this particular case, if the force is 4 newtons, it is equal to 2 kilograms times 2 meters per second squared. Okay? So if you wanted to, let's say, solve for a problem that says, what is the mass of an object that moves at an acceleration of 8 meters per second squared if a force of 2 newtons was applied? So it's moving, it has a force of 2 newtons. You're solving for the mass, and it is moving at a rate of 8 meters per second squared. So you want to know what the mass is. Okay, well, since we're solving for mass, mass is equal to force divided by acceleration. So we're going to divide both sides by 8 meters per second squared. 8 meters per second squared. And the answer you get in this particular case, 2 divided by 8, is 1/4 of a kilogram. Okay, so 1/4 kilogram or 0.25 kilograms. We typically, in science, we don't really use fractions all that much. We usually will go with the decimal, but it will be 0.25 kilograms. Okay, and you can check your work by plugging it back in. 2 newtons is equal to 0.25 times 8. Okay, so 2 newtons would be equal to 0.25 times 8 if you were to multiply it. Okay, which is 2 kilograms meters per second squared. That's what a newton is, a kilogram meter per second squared. Okay, so I just kind of wanted to go over those two a little bit so that people understood how they worked. Hi, Cassie. So if you don't, if you had trouble understanding how that graph worked, and if you had trouble understanding how the formula worked, this should help you out a little bit. If you still have any questions, please feel free to drop me a comment. You should be able to drop a comment on this. You should also be able to drop me a comment either on our Science with Mama J Instagram page. Hope you guys have a wonderful night. Bye.